So we have looked at square roots, and we know that when we find a square root, we are asking what times itself equals that number, and the square root of 9 is 3 because 3 times 3 is 9. Okay. We also looked at the fact that if we have the square root of negative 9, there is no number times itself that equals negative 9. 3 times 3 is 9. Negative 3 times negative 3 is 9. So this does not have a real number answer. Okay? There is no real number whose square root is negative 9. Well, it was found in real-world applications that these type answers came up. So mathematicians, maybe scientists, had to come up with a way to deal with them. So they came up with the number I. And I is the square root of negative 1. I is defined to be the square root of negative 1. And this is where the imaginary numbers come in. You know, we've talked about the real number and the number lines, and I said there are such thing as imaginary numbers. Well, imaginary numbers are when I is involved. That's why it's called I. I is the square root of negative 1. Here's how it works. Let's say I have the square root of negative 4. Well, I know the square, or negative 4, is 4 times negative 1, right? What's the square root of 4? 2. And the square root of negative 1 is I. So the square root of negative 4 is 2I. If I have the square root of negative 100, this is the square root of 100 times negative 1. The square root of 100 is 10. The square root of negative 1 is I. So the square root of negative 100 is 10I. The square root of negative 144, these are all perfect squares, that would be 12I. So we're going to simplify square roots that are now going to be negative, and we're going to do it the exact same way we did before, except now I is involved. If I have the square root of negative 50, I ask myself what perfect square goes into 50? That's 25 times 2, but since it's negative, there's a negative 1. Well, I can take out my square root of 25. The square root of 25 is 5. The square root of negative 1 is I. And then my root 2, the square root of 2 is irrational, so it stays under the radical. So the square root of negative 50 is 5I root 2. You write the number, then the I, then the radical. Let's look at the square root of negative 48. What perfect square divides 48? 16 does. 16 times what? 16 times 3, and then I have this negative 1 because it's negative. So I take out my square root of 16, that's 4. The square root of negative 1 is I, and the square root of 3 is irrational, so it stays under the radical. So this is done exactly the way that we have been simplifying radicals, except if it's negative, you're going to put an I outside the radical in your answer.